14. Hey everyone, here is our 9.5 notes today. We're going to work on our sine and cosine trig ratios. So sine is just the trig ratio that represents the ratio in a right triangle of our opposite. So sine of whatever angle we're looking at, which will represent as theta, is equal to the opposite leg divided by the hypotenuse. And then cosine of an angle is equal to the adjacent leg divided by the hypotenuse. So if you haven't, you might want to watch the 9.4 video because that talks about our tangent ratio. And this is exactly the same as our tangent. We're just setting up different ratios with opposite and hypotenuse. A way to memorize all these is the TOA to know the difference between them. But today we're going to focus on just sine and cosine. We set up exactly the same. So I'm going to probably fly through a lot of these notes and skip a lot just because if you can do the tangent ratio, you can do the sine ratio without too much of a problem. So let's keep going. Down here is just talking about that opposite over hypotenuse, adjacent over hypotenuse for sine and cosine. Angle of depression. I should probably talk about that here at the top. So you know how angle of elevation we had, now don't draw this, we had like the ground and we're talking about this angle right here that I just drew. Angle of depression is going to be more of, we have the angle here and we were looking at something going downward. So like going down a hill, down a mountain, something along those lines. So that would just be in terms of we have a question and drawing it, it would be the angle at the top instead of the bottom. Last thing you need to know is sine and cosine are sort of complements of each other. And here's what you need to know. They have here that the sine of A is worth the the sine of A is worth the cosine of that angle's complement. And how that works, I'm just going to quickly draw a little thing over here. Here's a right triangle. You erase the stuff that doesn't look like the triangle. And let's say this is a 3. Actually, let's actually make this pretty easy. Let's call this a 30-degree angle, a 60-degree angle. We have our 90. So then we have our 1 to square root of 3 ratio here. Okay. Now, we know that 30 and 60 right here are complements. And part of it is we know that those two those two acute angles need to be complementary because they're both going to add with the 90-degree angle to equal 180 degrees due to the triangle sum theorem. So, with that being said, if I looked for the sine, let's look at the 30-degree angle. The sine of my 30-degree angle is worth its opposite, which is 1 divided by its hypotenuse, which is 2. Now, if I look at my cosine of 60 degrees, that would be its its adjacent, which is 1 divided by the hypotenuse, which is 2. Notice the two fractions are the same, but more importantly, notice that the angles are complementary. So let's go ahead and do some example problems. I'm not going to do all of this right here, but let's just go ahead and at least sort of set some of it up. This says we're going to find the sine of f, the sine of g, the cosine of f, the cosine of g, write each answer as a fraction and as a decimal round to 4 places. I'm not going to do the decimal. I'm just going to write the fractions because I think that will be more helpful in our situation. So let's look at number 1 here. And so if we go over here to number 1, I'm going to maybe try to zoom in just a little bit more. There we go. If I want to find the sine of f, so I'm just going to write sine of f. My sine of f would be its opposite, which is 12, divided by the hypotenuse, which is 13, and that just so happens to be a simplified fraction. Now, if I want to do my sine of angle G, its opposite is 5, its hypotenuse is 13. Now let's look at cosine. Cosine of f is the adjacent, which is 5, divided by the hypotenuse, which is 13, And then we know that the cosine of g is going to be its adjacent, which is 12, divided by its hypotenuse, which is 13. What I want you to pay attention to is that when I looked at the sine of angle F, sine of angle F is also the same as the cosine of angle G, because F and G are going to be the complementary angles like we just talked about. What I also see here is sine of G and the sine and the cosine of F are also identical. But normally you just have to simplify those fractions and write them into 4 decimal places. I'm not going to do the other 2 because it's just like the trig functions. Now let's just do number 4 here. Write the expression in terms of cosine. That means I want to find its complement. So I'm going to think of what's 90 minus 9. That's 81. So sine of 9 degrees is the same thing as the cosine of 81 degrees. So if we go to the next page, I can look here. We want to write cosine in terms of sine. So again, I'm going to find the complement. So it's 90 minus 15. I'm going to get 75. So cosine 15 is the same thing as the sine of 75 degrees. It'll be that same ratio, that same value. I'm going to skip 8 and 9 because we don't need that. And then let's just do question number 10. Again, we've done this with trig. Let's go ahead and do it with sine and cosine. We want to find these different angles, these different side lengths here, using our trig functions, no Pythagorean theorem. So let's look at 16. If I look at angle 16, my opposite is my x, my hypotenuse is my 9, and my adjacent is my y. If I want to find the sine of 16 degrees, it's equal to the opposite, which is x, divided by the hypotenuse, which is 9. To solve this, I'm going to multiply both sides by 9, and I get x equals, rounded to 1 decimal place, 2.5. I can look at the cosine of 16 degrees, which is worth the adjacent, which is y, divided by the hypotenuse, which is 9, multiply both sides by 9, and I get y equals 8.7 if I round that to 1 decimal place. Again, same process we had with tangent. I just wanted to show you what we could do there. If your variable is on the denominator, we just have to make sure you can solve that equation. So really quick, let's just start number 12 here. If I look at number 12 and I look at 47 degrees, I have my opposite, I have my adjacent, and I have my hypotenuse. Now I cannot have 2 variables in the same equation, so I have to start with using my opposite and my adjacent, or my adjacent and my hypotenuse, whichever one I want. But let's go ahead and do adjacent over hypotenuse. Let's do cosine, because we're not doing tangent today. So we have cosine of 47 degrees equals the adjacent, which is 10, divided by the hypotenuse, which is d. What do I do here? I now need to technically swap these. So I'm going to get d equals 10 divided by the cosine of 47 degrees, and I get d is roughly 14.7. And I can write that 14.7 here. Then I can use that 14.7 as my hypotenuse to find the sine of 47. So you would set this up as the sine of 47 equals its opposite, which is c, divided by the hypotenuse, which is 14.7. That's where I'm going to stop with the notes today. They're very simple, very basic. So there you go. Have any questions, reach out. If not, we'll see you in the next video or on the next class. So have a great day.